I saved a startup over $1 million in token costs through prompt engineering, intelligent caching, and other techniques. Cost management is such an integral part to being an AI engineer. So it's important for you to not only be able to build AI systems that are fast and scalable, but also not insanely expensive. With AI now offloading a lot of the technical implementation part of our jobs, it is becoming more and more expected of you as an AI engineer to have this business mindset, where everything you do should be directly related to either generating money or saving money for the company that you work for. In this video, I'm going to show you the methods I use to save a startup over $1 million in token costs. And one of those ways actually involves putting more tokens into your prompts. What? How's that possible? Well, now you have to watch the video to find out. So a little bit of context. At this startup, I was onboarded to this project, which was a chatbot RAG agent. I know, revolutionary. And this company had been building this solution very quickly to have something to demo and onboard existing customers who were paying for other services on their platform. So at this point, there were really no focus on costs. And this resulted in a solution that looked very nice from the customer's point of view, but it had a very suboptimal architecture, and it was just burning tokens like crazy. We're talking about over $3,700 a day, and that's like $1.4 million a year. Crazy stuff, right? So the first thing I did is look through the flow and the architecture of the application to see what's going on. And what I found out was that even though you could search, full sentences, etc., but in this particular application, most users were searching using 1, 2, 3 keywords max. And the usage of these keywords were very normally distributed. So there were a couple of keywords that were being used all the time. So naturally, the first thing I did was implement caching. And I found out a really good way of caching LLM requests, and that's through Cloudflare AI Gateway. So you probably know Cloudflare from getting HTTPS for free and other stuff, but they're doing a lot of really cool stuff for building agentic applications. And one of them is Cloudflare AI Gateway. Basically, you get the URL, you slap that into your OpenAI wrapper, however you call your LLM API, you kind of just change the endpoint to go through Cloudflare like a router. And then it goes through their platform, caches it automatically. So if you have another request with the same identical input, it will hit the cache, it won't cost you anything, and it'll be returned to you super quickly rather than just calling the LLM again. Not only do you get this caching built in, but you also have this very nice observability platform where you can see, what types of LLM calls are costing you the most, which ones are taking the longest time. And it's a great way of evaluating your application. While we're on the topic of caching, it's a very important part, not only for cost management, but in a chatbot like this, latency is of course critical. Now, routing your LLM calls through Cloudflare does add some overhead on the latency. For us, we found it was well worth the trade-off of having a nice caching system built in, and the observability, of course. But what you'll learn as an AI engineer is everything kind of has a trade-off. So to mitigate the additional latency overhead, I sought to implement caching in other ways of the application. So I noticed we have, for example, an embeddings client, the OpenAI client we use for the LLM requests, the client for our vector database. These were all initialized on every run. So if the user searches a question, we have to create all these clients every single time. And that makes no sense because these clients should be able to be reused across runs. It's the same client anyways. So what I did is I used Redis to kind of cache the initialization of these clients so that on subsequent runs, the client is already ready and we can just route requests to there. That really helped us bring the latency down to much lower levels than before we even started using Cloudflare AI Gateway. So take a look at your application and take note of where you're initializing clients and see if you can cache those. Now, caching clients across runs, it can lead to memory leaks. So that's something to kind of keep in mind and research. And the same technique I used for caching, retrieving secrets. We stored secrets in GCP Secret Manager. This is just another API call to get these, and these secrets should be cached as well, which also reduced the latency a lot. So you see, me coming in to dig into bringing down costs in the application also led to me identifying the bottlenecks on the latency. So this all ended up in a much cheaper and much faster application. So I guess that's a tip I would give to you is if you're trying to bring your costs down while you're at it, digging around in the core architecture of an application, you might as well see where you can bring down latency as well to just make it a better application overall. The next thing I did is upgraded us to the OpenAI Responses API because they were on completions before. And the reasons for this, I mean, I'm not a huge fan of the Responses API. It's kind of led to a lot of issues, especially with using some OpenAI models. However, it does a better job at prompt prefix caching. So in this scenario, we had a huge system prompt, and then there would be a user message, like whatever the user would put in the chat box, right? And if you're sending this to the LLM, the system prompt will never change. It's just the instructions of what to do once you get the user message. Usually the dynamic part is the user message. And this means you can use something called prefix caching, which I think OpenAI has done a horrible job of documenting because it's such an underrated feature. But the way it's implemented is just so strange, honestly. The last time I looked into this, they said that this works on completions API as well. I don't know. I didn't get it to work on there, to be honest. It wasn't until I upgraded to responses that it actually started working for me. So what you need to do is take a look at your system prompt. If there's any dynamic content there, maybe the language that you're instructing the LLM to output in, if you have a multilingual chat application, put that stuff at the end. Put as much dynamic stuff at the end as possible so that everything else can be cached. Because if there's even one letter of dynamic content in the beginning of the prompt, then everything else won't be cached. Secondly, and the weirdest thing is your prompt needs to be at least 1024 tokens. So strange. I mean, we had a pretty big prompt, but it was less than that. So I ended up having to put in some additional context just to hit the token limit, just so it could cache pretty much the entire system prompt. Yeah, Sam was not cooking with that one. Crazy example how putting more tokens into your prompts can make it cheaper and even faster. What? We live in such a crazy time. And the second part is, of course, the prompt engineering. Basically, in this application, once the user submitted a question or a query or a search, we'd vectorize that, use that to retrieve embeddings from our vector database, which we would then transform into the houses that this startup was listing. And basically the actual retrieval just couldn't be relied on. I guess the embeddings just weren't good enough. We did all try to improve the embeddings, but nobody really got anywhere, which is why they implemented an LLM-as-a-judge solution. So for let's say for one question asked, you get 50 houses back. All those 50 houses are JSON objects that will be sent into an LLM-as-a-judge to just go through everything and make sure it's relevant to the original query from the user. This was the most expensive LLM call of all of them by a long shot. So here I started looking into, what are we sending to this particular LLM call? It was a nicer model because it needed to be smarter. So downgrading this wasn't really on the table because the results suffered so greatly then. But I started looking into this JSON object that we sent in, and realized we're sending in a lot of fields that we probably don't need. I was just thinking about, this LLM call, what exact info does it need to actually determine if this result is relevant to the question or not? And there were maybe one or two fields too many there. And this might just seem like nothing, but when you're sending in 30 houses in a JSON array at the same time, and you're doing that multiple times a day, and you have high traffic on a website, which this startup did, that adds up. Just trimming down the JSON sent in for each house listing like really brought down the costs here. Basically, like the golden principle of AI engineering is just try to remove things until it breaks, basically. Like once you have a good performance baseline, just like it's probably expensive, it's probably slow, just start trimming it down until you get to like the golden spots. Also, if you have a fat prompt, like you should really try to consider splitting that LLM call into multiple LLM calls, because probably some of the stuff that prompt is doing, it doesn't need all this brain power for, so it should go through a cheaper model. And that's a good segue to my next point, which is prompt routing. So prompt routing is basically when you take an input and then you either programmatically or using AI determine which LLM or which prompt. So you can split into multiple calls, and you might find that maybe you won't even always need all these calls, all these LLM calls. For example, maybe some of the stuff that the LLM was trying to do, you can probably achieve programmatically. An example here was this startup was selling real estate listings. So one of the things that we would do is we'll take the original question, which could be like, hey, I want an ocean view penthouse. And we'll use an LLM to decipher, oh, ocean view, maybe we should show, waterfront, beachfront, like all the similar amenities. This can just be retrieved with regular expressions. If you have a lookup dictionary, this will resolve instantly, pretty much. And it will be free. Just always have in the back of your mind, how can I achieve this programmatically? Is it feasible? If it is, then it's probably worth the time to implement it, so you can trim down your prompts. Also, analyze the usage of the application, or just try to think of what is the most probable scenario here. Like if there is a case where 90% of users will go through this path, that's the path we want to focus on optimizing the most, right? And that was the case here. Like I said, most searches were normally distributed. Since there were many flows in this RAG chatbot, I mainly put my focus on optimizing the path that was the most used. Okay, so back to this LLM-as-a-judge step, which I mentioned was by far the most costly. Using a large language model might not be the best way to filter out false positives. There are actually re-ranker models that are especially trained for that. So that's why I implemented bge-reranker-base. Like, I don't have anything to say about this. It's just the one that was available on Cloudflare at the time. So basically, you take the JSON array of the house listings that the LLM was supposed to re-rank, but you send them into the re-ranker instead, along with the original question. And the re-ranker model it's not a large language model, it's a much, much smaller model. So it's so much faster, and it's like fractions cheaper than using a large language model. And this will return all the objects to you with a score of each one. So basically, this is just a first pass to filter out the really bad candidates. Like here's where we actually converted the scores to a sigmoid, basically to like kind of normalize it. And then we put a threshold that like any house that's below a certain sigmoid score here, we'll just automatically discard. And then we put another threshold that if the sigmoid score is like above like 0.94, it goes from 0 to 1, then we can already consider this a good result, and we just return it directly to the front end. But if it's between that high threshold and that low threshold, we don't really know. So those are the only results we send to the LLM-as-a-judge, which meant we significantly reduced the amount of tokens we used for the LLM-as-a-judge, because there's just way less JSON objects that it has to go through. It also made the application so much faster, and this was probably one of the biggest cost-saving techniques. So if you find yourself with an LLM-as-a-judge scenario here, most likely it is quite expensive. Try to opt for using a re-ranker and then mathematically filtering out the bad candidates, only sending the really ambiguous cases to the large language model. This particular technique is actually something I've brought up a lot of times when I do my AI engineer interview prep coaching calls with some of my subscribers. And that's something that people report to me, that they bring that up in their interviews, and it's really left a positive impact to the interviewer, as it's quite a good technique of bringing down costs while also maintaining, or it might even improve, relevancy. So I highly recommend just adding that to your arsenal, keeping it in the back of your head. Those are kind of like the more fundamental things that brought down costs, but I also did a couple other things, but these were quite insignificant compared to the others, but still worthy of mentioning. And one of these is reduce the dimensions of your embeddings. So we had a 1024 originally, and I ended up reducing it to 768. What this basically means is you're storing less data, so your data, your vectors have less granularity, but because you're transforming and storing less data, it's also a lot cheaper when you're hitting the embedding model, of course. Now this, like I said, it didn't have the hugest cost-saving benefit, but stacked on top of all these other small things I did, it did add up. And OpenAI actually suggests that anything more than 768 dimensions is probably overkill. We certainly didn't see any reduction in relevancy when dropping to 768 dimensions. Also, of course, I touched on this before, but just always trying to split things up and switch to smaller models. Like we found we had some processes in the systems that we could actually use GPT Mini and Nano for, which are so much cheaper than the other ones we're using at the same time. That one's just worthy another mention. And I bring this up again because when you downgrade to a model, it's really useful to have evals. I mean, this goes for like any of the optimizations I brought up here. If you have evals, then you have kind of like a golden data set, a ground truth of inputs that you know should result in a certain output, more or less. So very handy to have when you're downgrading models, so that you can very easily and visually confirm any regressions, and that will just help you find that sweet spot zone we talked about before. Another thing is this was of course a chatbot, so there's a history component. Some users were having very long sessions, and basically then you have to send in the entire message history into every LLM call you make, which just compounds the cost, right? So after a certain point, we put like a 5-message limit. After that, we just started compacting the context. So we actually used LangGraph has a summarization node for this, which is super useful. It will basically just take your chat history and just summarize it into one message. So you don't have all this noise about like, hey, I want a 3-bedroom house. And then you're like, oh, and now I'm looking for a place with a pool. That could be compacted to like. So yeah, that's basically some of the things I did to reduce cost in this company, I kid you not, by 90% on token usage. And a lot of that was because they had such high traffic that all these like seemingly small things just added up in so much cost savings. And especially just the caching alone like really brought stuff down, because we saw a bunch of repeat queries. And of course, the company was super happy about this. And it gave them so much more runway. So the reason I made this video was because it's such an important thing to know when you're developing AI applications, to also keep costs down, because we can build so fast now with AI, but the overhead can just add up, and it can just like, you can very quickly make inefficient systems that not only lead to a lot of bugs, but that also are not very cost optimized. And companies are just starting to use more and more tokens at an exponential rate. I mean, now using like reasoning and stuff. So like having a way to mitigate cost is super useful. And especially if you're looking for a job, like these are the things you want to bring up to impress your interviewer, and it will show them that you're a good candidate to hire. But yeah, that's all I have for this video. Thank you so much for watching, and I'll see you later.